So now we go into the portfolio method. Then I remind you again about the required rate of return comes from the risk free, yeah, the risk free, and then the risk premium, yeah. So K is equal with KRF plus KRP. Then the rate of return from the portfolio, we call that as the expected return. So no longer rate of return. Usually, if we say about rate of return, it will be the return from a single asset or a single investment. But for portfolio, we call that as expected return. Yeah, so that's the same, but actually portfolio, we use a different term for that. Right. So the expected return of a portfolio is equal with sigma, or the sum of the portion of the return from an asset. Okay. So this is the portion, and this is the rate of return from an asset. Okay, so for example, if there are 3 assets in one portfolio, okay, so say A, B, C stocks. Then we have the KA, and now we call that expected return of A, expected return of A. Then KB is expected return of B, and the KC is expected return of C. Then in that one stock, we have the portion, or we call that as weight of the K of the stock A is, say, 10%. Okay, for example. Then the WB, the weight of B is 30%. Okay, then in one stock it should be 100%. So the WC will be 10 plus 30 is 40. 100 minus 40%, it should be 60%. So this is what we call with portion or weight. Okay, got it? Right. Then after that, the expected return of this portfolio will be the weight of A times KA plus weight of B KB plus WC KC. So like this. Okay. Now, what about the risk? The risk of one portfolio, we call that also as the standard deviation of the portfolio. But now, in this formula, we use only 2 assets in one portfolio. Yeah. So this is formula, the risk formula for 2 assets in a portfolio. So you see here there are only 2, A and B. So sigma portfolio, or the standard deviation of a portfolio, is the square root of WA quadrat times sigma A quadrat. So again, this is the weight, and this is the risk of one asset, of the single asset of A. So you have to calculate the risk of the A, like in what I have explained in the previous, and the WB, and then plus WB square times sigma B square plus 2 WA WB correlation of A and B, and sigma A, sigma B. Alright, so, well, in your case, this is given, yeah, in your case. But actually, in real case, we can calculate the correlation between two data, right? I think you have you have studied that in business statistics, how to calculate the correlation between two data and also the standard deviation of one data, standard deviation of second data, etc. So yeah, then it's given, and you just doing the operation, algebra operation, done. Okay, so this is the example. We have a portfolio which comes from two funds or two assets, which is this asset is actually the index. I will explain later if we are in the class about what is index mean. And the second one is the international fund portfolio. So the expected return for each of these fund is given like this: S&P 13%, international fund portfolio 17%, and also is given, yeah, there is 11% for S&P, 15% for IFP. Then the proportion or the weight, you see here, it's always 100%, always 100%. So you can check it actually if the weight is correct or not. If this is 40%, then sure, the other one is 60% if there are only two assets. Okay, and it's also given the correlation coefficient or rho is 0.75. So calculate the portfolio expected return and standard deviation. Okay. So now calculate the expected. First of all, given first. Given. All right. Expected return or rate of return of S&P is what was that again? 13%. And the W S&P is, the weight of S&P is 40%. Oh, there is the risk of S&P is 11%. Yeah, 11%. And the expected return of international fund portfolios, I call that IFP. Yeah, it's 17%. Right. And then the weight of IFP is 60%, and the risk of IFP is 17%. Is that? Yeah. Sorry, 15%. 15%. Right. So first of all is the expected return of the portfolio. So that will be the sum of WI with expected return of an asset. Yeah. So if we have 2, then this is start from 1 until 2. Okay, so that will be what is the way as P A, or written as P, and then W I, not way, sorry, W I F P times expected return of IFP. So now this is 40%, and this is 13%, and this is 60% times how much? 17%, correct? So, well, that will be 5.2%. Yeah, 14 times 13 is 520 divided by 100. So that's 5.2. Then 60 times 17 is 1020. So this is 10.20%. So that will give you 15. Yes. Yeah. 0.4%. So this is the expected return of the portfolio. Then the second one is the standard deviation or the risk. So we call that sigma p, and that is the square root of square WA S&P quadrat sigma SP quadrat IFP quadrat sigma IFP quadrat plus 2 WSP times WIFP times rho between, oh yeah, I forgot the rho, yeah. Okay, what is the rho again? From the statement from the question is rho between S&P and I is 0.75, yeah. Okay, so this is correlation between S&P and IFP, and then again sigma SP and sigma IFP. Okay, so omega, what is that again? WA quadrat, what's that? 40. So 40% quadrat, this is 4, yeah, times, be careful with this is not difficult things to do, but plenty of detail work that needs to be taken care of and very careful. So this is 11%, way IFP is 60% quadrat. Wow. And then what again? Sigma IFP is 15% quadrat plus 2, 40% times 60% times 0.75 times 11% times 15%. Okay. So will be, sorry. Well, now 40% quadrat plus 11 quadrat is, so this will give you 19.36. So like that. So I convert the percent quadrat into 1 divided with 10,000, and I leave it that way, the percentage in quadrat, yeah, plus 60 quadrat times 15 quadrat, that will be 81% quadrat plus 2 times 40 times 60 times 0.75 times 11 times 15. 11, 15, 0, yeah, okay. And again, I convert the percent quadrat. This is percent, so over the 4, sorry, a power of 4. So I convert only quadrat of percent. Then it will give you 59.4% quadrat. So this will give you, we have the same unit of percent quadrat, so you just add it, plus 81 plus 59.4, so that will give you 159.76% quadrat. Then I let the percent quadrat as a percent, yeah, out from the square roots. Okay, you following me? Percent quadrat, square root of percent quadrat is percent, right? Then square root of 159.76 is 1263. So this is the answer. Now, as the conclusion is that you say the expected return of this portfolio is 15.4%, 15, yeah, and the risk is 12.13%, like that. Okay, understood? I hope you understand. So now I will introduce you the required rate of return using capital asset pricing model. So in the previous, I said that K is equal with KRF, that is free rate of return, plus K premium. Yeah, so this is the risk the return from the risk premium. It comes from the company itself and it's come from the country. So now there is another theory, yeah, on how you calculate this by using the market base. Okay, so capital asset pricing model based on the beta, which the beta is the I have explained before. The beta is actually the risk of, did I have explained this? I think I have, yeah, or I haven't. Oh, I haven't explained about this. So beta, so in the previous slides I've said that the risk can be calculated through the standard deviation, right? But now this is the risk. Beta is also the risk, but the risk of an asset, yeah, based on the market. Yeah, so if the risk over here, the standard deviation is only the risk of one asset alone, of an asset alone. Yeah, so actually asset is also how do I say that, not control, yeah, but influenced by the market. Okay, the price of stock cannot be stand alone. It always influenced by the surrounding market, of course, or the surrounding conditions about the country, right? So the market of us, the market here is actually the financial market. Yeah. What is actually the benchmark of our market, Indonesian market? So this will show the country market in financial term, in investment world. Yeah. So basically the thing that people will see, how about Indonesian market, financial market? How about the Singapore financial market? Through the index. Yeah, index of stock. So we have plenty of stocks actually. In one country there are hundreds of stocks, and then from all of the stocks, every country made the average of their return of the stocks, their stock returns, yeah, the average of the stock returns in that country, and also the average of the risk, yeah, from all of the stock that the country has. And that average of the return, we call that as the index. Yeah, so the index of stock in Indonesia called with IHSG or JKSA. Okay, yeah, so this is the indicator of how is the Indonesian financial market. So I think you have heard this, yeah, but maybe you don't know much about this, do not know deeper yet, but now you have, now you know, and you can, yeah, you can read what is IHSG is, and how is the fluctuation, how is the trend of IHSG, like that. Okay, back again here. So I'm saying about beta, the risk. Yeah, so cap M specifies a linear relationship between risk and required return. So in here, yeah, in our previous model, we just say that K is not depending on the risk over here. You don't see any sigma in here, right? But here in cap M, there are risks here. Yeah, I cannot derive the formula for this. This is actually if you want to go deep in here, so you just go to the class of the investment class. Yeah, in regular class. Okay. So cap M is equal with the risk-free rate of return plus beta times the market rate of return. So Km is the market rate of return. So the return of the index over here minus the risk-free of return. So this is how you want to see the rate of return from the stocks throughout the market point of view. Okay, so this is the example of how to use CAPM, right? Given. Well, find the required return on a stock given that the risk-free rate is 8%. The expected return on the market portfolio is 12%. So you see here, required return on a stock, we call that required return. But if we say return for portfolio, we call that expected return. Yeah. And back to the example here. And the beta of the stock is 1.5. So given here is KRF is 8%. So you see this is given, yeah. And expected return on the market portfolio, because index is again the average of the return from the portfolio. So index of the stocks in a country, stocks, yeah, so that's more than one. So that's why we call that as the market portfolio, right? So again here the expected return of the market, or yeah, in that cap M formula is what's that again, K, sorry, where is this first? So the K of a stock is equal with KRF plus beta Km minus KRF. So this is the expected return, yeah. It should be expected return Km or expected return. So yeah, see the inconsistency of the the symbol in management is like that. So just beware of that. Well, okay, then this is 12%. Beta is 1.5. So the answer is K of that stock is KRF is 8%. Yeah, here plus 1.5. Km is 12% minus 8%. So that will give you, how much is that? 8 plus 1.5 times 4. So that's give you 14%. It's a piece of cake, yeah? Because for you it is given. But if you are in the investment class, yeah, you have to calculate it one by one. Calculate this first, and then this first, then yeah, you will find this then. Okay? So this is another CAPM example. Find the beta on a stock given that its expected return is 12% and the risk-free rate is 4% and the expected return on the market portfolio is 10%. Stock given expected return. Okay, the return of the stock here is 12%. Yeah, and the risk-free rate is 4%. Expected return of the market is 10%. So what is beta? Again, the K from the CAPM is KRF plus beta KM in KRF. So you just fill in the number here. So you don't have just remember memorizing one formula. You just put the value here, fill in. So beta, I just let it as a beta. Okay, M is 10%, then here is 4%. Okay, so 12% minus 4% is equal with beta. 10 minus 4 is 6%. Okay, so beta will be 8% divided with 6 is, how much is that? 1.333. 8% divided by 6% is 1.33. So that's all. Okay. Yes, and that last example is the last slide from the risk and return material. So thank you for that, and make some questions for me, as many as possible. Okay, goodbye.